Assalamualaikum warahmatullahi wabarakatuh. My name is Octaviani, and also my friends is Abdiilah, Iman, Izzan. In here, we want to present our research report entitled Effect of the Ratio of Hazeolite, Catalyst, and Temperature in the Opening Ring Reaction for Bioloop-based Oil Production from Palm Oil. And the first thing that we want to show to you is the outline of this presentation. The first is I want to show you about the background of this research, and the second is the problem formulation, why this research came out, and also the objective. The next is the reaction mechanism, the experimental design, result, and also the conclusion. And the first thing is about the background. Actually, we also now, based on the data, Indonesia is one of the member of East Asia country, and the data says that in 2015 until 2020, we also the data shows that the demand of the lubricant is always increasing, and the increment is reached the value of 4.7% in 5 years. And this data shows that our demand of the lubricant is always increased, but in Indonesia itself, the fulfillment of the procurement of these lubricants, 85% is fulfilled by the fossil fuel based oil or fossil fuel lubricant, and this is becoming our chance to seek the other potential crops, and one of them is the palm oil. Why the palm oils came out? Because the palm oil have several advantages that could be the potential things that we can take for produce the lube-based oil. And the next is the problem formulation, and this problem is actually shows that the first thing that we see is the increasing of the demand of the lubricant, and the second thing is the current lubricants, and it's fulfilled 85% by the fossil fuel oil. So this is not environmental friendly. So this biodegradable from palm oil is a good reason to choose. And the second thing is we also compete with the properties of this natural palm oil, because the natural lube-based oil have not stable structure, that it could be make and not good properties for lube-based oil. So we can improve it from the method, and also the catalyst itself, and also the cost. And several researchers, the current researchers, is already shows that there's a good catalyst to improving the properties of the palm oil itself, but the price of the catalyst is very high and it's highly costly. So we give you the solution to take the hazeolite from natural zeolite to face these things. And also the objective of this research, the first is to determine the manufacture of lubricating oil with palm oil as raw material using trans-esterification reaction, epoxidation, and also ring opening reaction. The second is analyze the influence of hazeolite catalyst weight ratio with palm oil on viscosity, density, acid number on ring opening reaction. And the third is the analyze the effect of ring opening reaction temperature in viscosity, density, and also the acid number in the opening ring reaction.
We talk about reaction mechanism. The first one is trans-esterification. Trans-esterification is the first step for making lube-based oil. The purpose of trans-esterification is to break down long carbon chain to be simpler by generating palm oil methyl ester. The reaction stage begins with the mixing of base sodium hydroxide catalyst with methanol, forming an alcohol ion. Furthermore, alcohol ions invade carbon-carbonyl atoms and triglyceride molecules from the intermediate substrates. Then the substrate reacts with the alcohol forming another form substrate that will undergo the rearrangement process into palm oil methyl ester and glycerin. This is the experimental design. The first thing we do is trans-esterification reaction in a batch reactor. In this reaction, palm oil is reacted for 1 hour with methanol with the help of sodium hydroxide catalyst with a reaction temperature of 65 degrees Celsius. The product of this reaction are palm oil methyl ester or POM and glycerol. The POM from the reaction 1 is separated and entered the epoxidation reaction. The reaction takes place in a batch reactor for 1 hour and the temperature of 65 degrees Celsius. Palm oil methyl ester is reacted with peroxide acid with the help of a formic acid catalyst. The reaction produces epoxidized palm oil methyl ester or EPOM, water, and formic acid. The EPOM is separated and enter the ring opening reaction. The reaction lasts for 4 hours. Reaction temperatures are 55, 65, and 75 degrees Celsius. The amount of zeolite catalyst used is 1% by weight of the EPOM, 5%, 10% by weight of the EPOM. Then, the product of this reaction is modified EPOM. We call it modified EPOM, which will be tested for its characteristic. The test consists of a density test, viscosity test, and acid number test. In these experiments, the tools we use are pygnometer, pumpkin neck tree or batch reactor, condenser, magnetic stirrer, thermometer, separator funnel. While the materials we use are palm oil, methanol, glycerol, sodium hydroxide, peroxide acid, formic acid, natural zeolite, and aqueous. What variables in this research? For the fixed variable are all variable in trans-esterification and epoxidation reaction, while for the modified variable are azeolic catalyst ratio consists of 1%, 5%, and 10% weight of EPOM in ring opening reaction. And the second one is ring opening reaction temperatures consists of 55, 65, and 75 degrees Celsius. For the product analysis, there are 3 kinds of product tests. The first one is viscosity test. The viscosity test can be done by using viscosimeter tool named NDG5S digital rotary viscosimeter. The second one is density test that can be done by using pygnometer. And the last is acid number test. Acid number on the lubricant can be done by referring to the STM D974 method. Now, we discuss the effect ratio of azeolic catalyst and epoxidized palm oil methyl ester of ring opening reactions. The first one to the density. From the figure, shows that the greater number of catalysts added, then the density of the resulting product is greater. This is because more and more catalysts on variable, the greater the decline in activation energy, and the more numerous epoxide rings that the EVM opened by catalysts, along with the increase in the number of catalysts added, so that it will increase the number of glycerol that can be reacted. Now, we discuss the effect ratio to the acid number. If we compare the product in this research with the mineral lubricant HVI 160 and UBS, which has successive acid number 0.98 and 0.58, then all products of this research have a much higher acid number. The high number of acids can be caused by the presence of the catalyst residual acid impurities that are not completely lost at the time of washing. To handle this, it can be done by the neutrality of the residual acid using sodium carbonate on the washing process. The effect ratio of azoylase catalyst and epoxidized palm oil methyl ester of ring opening reaction. 2. Viscosity as index viscosity. The figure indicates that the value of viscosity tends to increase with increasing number of added azoylate catalysts. The larger of number azoylase catalysts added, the more glycerol group containing the polar OH group added. So, the tensile style of pulling between molecules will be greater, which will result in the greater resistance that is possessed by the resulting product to pull. So, the higher catalyst ratio, the product viscosity increases.
The next is the effect of ring opening reaction temperature to density. From the graph, we also see that the increment of the density is happen in each of the variable of the ratio and also the temperature itself, but the higher value is reached by the 75 degrees Celsius variable in the 10% weight of Hasil. This condition is from the theoretical from Zhengse et al. Says that the ring opening polymerization of three-membered rings is thermodynamically favored because from the equation delta G equal with delta H minus T point delta of entropy shows that the delta H of enthalpy of this ring opening polymerization reaction is negative, so it will be impact to the temperature glass itself. In the increment of the temperature glass is happens followed by decreasing of the free volume and create the higher cross-linking density. So if we doing the higher temperature of reaction, so that the density it will be increased too. The second things that we see is the effect of ring opening reaction temperature to acid number. The total acid number is to check is any formation of free fatty acid formed during this reaction. And in all of the graph, we can see that the decreasing is happen in all of the variable. Start from 55, 65, and also the 75 degrees Celsius is also decreasing until the lowest value is 1.847. And this happened because in the higher temperature it will be more reactive hazelate, so it will decreasing the acid number. But the requirement of the lube base oil, the total acid number is not more than 0.5, and all of the data that we have is above the 0.5. It happened because this hydrolysis of triacyl glycerol backbone to form the free fatty acid, so it makes the total acid number is higher than 0.5. Next is the effect of ring opening reaction temperature to viscosity as index viscosity. In this graph, we also see that the increasing of the value of the viscosity until 278 is reached by the 75 degrees Celsius of the temperature of ring opening reaction and 10% weight of azolate. It reached the highest viscosity index because in this occurrence the reactions it happen more rapidly because of the rate of the reaction is higher, and in this complete ring opening reaction this condition can to form the thioether derivatives of hydroxy vegetable oil, and in the higher of temperature it will creating much of this thioether derivatives and creating the higher of molecule weight. After the molecule weight is higher, so it will create the viscosity index is higher too. And we jump to the conclusion of this research report. The first is the quality of lube-based oil. It could be indicated by the density, also the viscosity, and the acid number. And the acid number will smaller in the percent higher content in 10% weight, followed by the density and also the viscosity index. So in the higher presence of the Hasil, it will improve the product of the bio-based oil. And the second thing is the effect of ring opening reaction temperature to density, viscosity, and acid number is the higher temperature will make reaction reach optimum condition and improve the properties such density, viscosity, and also the decreasing the acid number. And the third is the effect of ring opening reaction to density, viscosity, and acid number is higher, and it will make the reaction reach more optimum. But several problems like self-esterification of polymerization leads to indesired product and makes several product doesn't meet the acid number standard. Thank you.